Hey team, Andre from High Performance Academy here. Welcome along to another one of our webinars. Today we're going to be diving into the world of Autosport connectors. We'll find out what Autosport connectors are, why they're useful in a motorsport environment, and some of the aspects that you need to understand when you are coming to spec one for your build, and of course how you go about actually assembling an Autosport connector, pinning them and depinning them. Before we jump into that though, I'll just cover off a couple of things that have been going on around here over the last week or so. And to start with, if I can actually find my notes here, yeah, we're running another one of our giveaways. This one's only got 4 days left to run, so it's in its final stages, and I'd suggest if you're interested in learning how to build your own engines, this would be a great one to win. So this is a full ProForm engine building tool set, and on top of that we are also including our suite of engine building courses. Total value there over $2,000 US. You'll get an electric piston ring file. Makes it much easier to gap your rings consistently across the full set compared to a manual ring file. Nice fact with the ProForm electric ring file as well is it does include a dial indicator on it, which makes it a little bit easier for you to be quite accurate with how much material you are removing. Again, this just helps speed things up. Another thing I really like about the ProForm electric ring file is it does have a little stop on it, which makes it really easy to set up the ring file to suit your bore diameter. And the reason we want to do this is it just makes it much easier to get consistent parallel ring end gaps rather than a big taper, which we so often see. It can be quite hard to manage as well. On top of that, there is a rod bolt stretch gauge, a dial bore gauge, and a micrometer set. And again, we've got our suite of engine building courses. So if you are interested in building your own engines, this is the perfect way to get a head start on that. 4 days left to run. I'll get the team to drop a link into the comments you can follow to get your name into the draw. There are also a few other tasks that you can complete, which will give you more entries. Just another little update on our SR86 project, and I have been talking about this a little bit. You're going to have to bear with me. I've got more to talk about, but we are getting really close to testing again. We were hoping to go testing last week with the new aero on it. Didn't quite happen. Still a little bit of work left to do on the new front bumper. But one of the aspects that we are quite excited about getting on this car is the shock travel potentiometers, or shock position sensors. So jump across to my laptop screen. This is on the front end of the car, and you can see the sensor here. So this is a Penny and Giles sensor, just a 0 to 5 volt linear travel potentiometer, and as you can see, it's been mounted between the chassis and the lower control arm. A little bit tricky with these to actually fit, particularly the front, because we obviously need to make sure that they stay clear of the wheel as we turn the steering. So not a lot of room to work with, particularly on the 8.6 chassis, but Jimmy, our fabricator, did a great job of getting those in there. One of the aspects that needs to be considered here is also calibrating the sensor so that it is actually giving us a true indication of the wheel travel, because obviously where that's located there is a motion ratio between what that shock pot will be doing and what's actually happening at the wheel. Now, why have we got these on the car? So there are a couple of reasons for this. In general, they can be a really useful tuning tool for optimizing our bump and rebound settings on our dampers, and we do this in conjunction with a shock travel histogram, and basically we can see the reaction of the damper to bump and rebound travel. So that's one really useful tuning tool. Most data analysis packages will allow you to analyze the performance of your dampers using this information. Key input there, or key factor to consider, is that in order to get good data with a shock histogram, we do need to be logging this data at a reasonably high frequency, somewhere around about 500 hertz. That is a consideration. Obviously, we've got 4 of these on the car, and if we're logging all 4 at 500 hertz over the course, particularly of a longer race, that is going to impact your available analysis or data logging memory. So just a consideration there. Now, it's not just useful though for our damper tuning. The other reason we've got this on the car, or these on the car, is that we're also going to be using these to help us with validating our aero performance with the aero kit, the aero components that are on the car, the front splitter, diffuser at the rear, and the rear wing. We are expecting a significant amount of downforce, and where this comes into play is that obviously at very high speed at the end of a long straight, we're going to end up with all of that downforce pushing the car harder down into the ground. The problem with this is if we don't deal with this properly, we end up with the car bottoming. That's obviously not safe. It's not going to be ideal for performance. A couple of ways of handling this sort of situation. One of them, of course, is we can just fit much stiffer springs to the car. That will work at high speed. It'll keep the car off the ground. The downside with this, though, is it will hurt the mechanical grip in the lower speed corners where we don't need to be anywhere near as stiffly sprung. So what Tim, our engineer, is going to be working through here is tuning our bump stops and packers so that essentially we can run a softer spring in the car than we otherwise would need to handle the aero load. But at the end of the long straights where we do have that high downforce to contend with, we'll actually be purposely running down onto the bump stops, and that will control the body height. The other thing with most aero kits where they've properly been designed is they will be quite sensitive to ride height. So they only work effectively over a relatively narrow range of ride height. So making sure that we've got the car in that window is important to get the most out of it. So that's at the front of the car. Of course, we've got the same at the rear. A little bit tricky to get a bit of a photo when we've got the diffuser, the splitter in place here, but you can see we've got that mounted at the bottom there to our SPL lower control arm, basically in line with the damper there. So pretty excited to test that out and see how things are going. A bit of an update as well with the rear of the car. Still a little bit of work to go, but all of the mounting of the rear wing and the diffuser is complete. Jimmy's fabricated up a new exhaust that's going to work with our new diffuser. And we've just got the rear bumper, or what's left of it, being cut up and placed back into location. So it looks a little bit more like a car and a little bit less like a spacecraft. One of the interesting aspects here is the way the exhaust is going to be integrated with this diffuser. I'll admit I am a little bit skeptical of this, but if anyone has followed Formula One for any time, you may remember the period where they were running blown diffusers. In my opinion, one of the most horrible sounding times of F1, except for maybe the present hybrid turbo engines, but that's just my opinion, don't shoot me. The idea behind it was that by blowing the exhaust gases over the top of the diffuser, it actually improved the aero downforce to the point where they actually developed engine mapping so that the throttle could essentially stay open and sufficient exhaust gas was still going out the exhaust system even when the driver was completely off the throttle or braking through the corner to help with that downforce. I'm not expecting Formula One levels of downforce here, but Freddie from TopStage has suggested that we incorporate this system with our exhaust, and that is what we're going to be doing. Early days yet, and it's definitely not going to be a paper gurney flap. This is just a dummy assembly that Jimmy has been working on here, and he's going to fabricate this out of aluminium. The other aspect here is this exhaust tip that we've got at the moment is actually temporary. We're expecting that for race conditions, we won't actually run a rear muffler on the car at all. The turbocharger does a pretty good job of removing a lot of noise from the car, and we're allowed to be at 95 dB for race days. However, for our testing at Highlands Motorsport Park during members days, we're actually limited to only 75 dB at the boundary, which is relatively quiet. A factory Porsche 991, for example, is above that limit. So this muffler is there so that we can actually do some testing on our members days. So ultimately what's going to happen when we've got no muffler in there is Jimmy will be designing a new exhaust tip which will be sort of flared out and a lot wider to hopefully get the most benefit out of the diffuser that we can. Again, I'm a little skeptical here, but we can only take the guidance from the person who has designed and developed this at TopStage. So let's see how that goes. Now, another aspect that became a problem the last time we tested the car, we went to the track probably about a month ago now, and the aim was to do a good hour of running under hard race conditions, or as close as we could get, given we're the only car on the track, just to basically go through some of the cooling system issues we'd had. I've already talked about this in a previous pre-show. It actually worked out really well, but we were cut a little bit short. I think we ended up getting about 45 minutes of running total, and we were caught short because the alternator failed. Now, we were running the stock Nissan SR20 alternator, and one of the things that we do need to consider with this car is that there is actually quite a lot of electrical load on it. Despite it being a race car, one of the factors that we do need to consider is that it does run electric power steering. And off the top of my head, I think the electric power steer system in the car alone has something like a 100 amp fuse on it, which gives you some indication of the sort of current draw that can be expected. So the alternator died, we lost battery voltage about 3/4 of the way through, and basically that was that. So what we wanted to do is step up to a larger alternator, which is exactly what we've done here. Bit of an awkward shot down through the engine bay, but we've actually got an LS alternator now in place, which is a much higher current capable unit than the Nissan one that we're replacing. This is all sort of plug and play thanks to a EFI Solutions mounting bracket, so means that we don't have to go to the trouble of fabricating anything up. It's actually plug and play as well in terms of the connector, which was also a nice surprise. So that's kind of where we're at with the Nissan SR86 at the moment. Hopefully we'll be at the track next week to shake it down with the aero and see where we're at. We've still got a couple of months to go before the start of our endurance series, so suffice to say that we're in a much better place than we were this time last year, where we tried to complete an engine swap in about 4.5 weeks. There's still a lot to work through with the car, but we're a lot more confident that we're actually going to be heading into the first round with a car that's relatively well developed, has been shaken down and proven, and that's going to give us a bit more confidence going into our first race. But again, still a long way to go before we get to that point. Moving on, I just wanted to also show you one of the Instagrams I put up last week. This is actually a bit of an older one, but this is from the SR20 that is in our SR86. And I'll just bring this up so we can actually see it. Obviously, when we rebuild an engine, we are looking for an improvement in strength, particularly in this case, we're replacing both the factory piston, which is cast in the Nissan SR20, along with the factory rod. Now, usually when we go to stronger components, we do expect to take a bit of a hit in terms of the weight of those components. But in this case, we're quite pleasantly surprised there. We can see about 100 grams saving between the K1 Technologies conrod and the factory rod, and pretty much the same with the piston, which is a really significant weight saving when we consider how that's actually operating inside the engine. Now, one of the things that is important to understand when we're looking at the weight of the components that are inside our engine is that, particularly if we are wanting to get the engine to respond very quickly or change an RPM very quickly, the lower the mass of all of those components, the quicker the engine can respond. In our case, that's pretty important for the response on the gear shift, because with the dog engagement racing gearbox that we've got, it's sequential. We're not using a clutch for the upshift or the downshift. Upshift is not such a problem, but on the downshift, we really want the RPM to be able to change quickly so that the auto blip can match RPM, and that's a big help there. It also just generally allows the engine to accelerate quicker. Now, that's not actually going to make us any more power. You won't see the advantage of this on a dyno if you perform a dyno run, but what it will do is just generally allow the engine to accelerate quicker anyway. So anytime we can get weight out of our engine internal components and add strength, that's all good in my book. Just a reminder as well on our podcast, if you have been hiding under a rock, we now have a podcast which we're pretty excited about. We have a new episode comes out every Tuesday. If you do want to find those, you can head to www.hpatechtorque.com. The episode that has just been released is on a 1150 horsepower 1100 kilogram E36 BMW hill climb car. So if you want to go check that out, go and listen to that on any form that you normally listen to podcasts. You'll find us. Please also leave us a rating and review. And if you do leave us a review, you'll also go into the draw to win an HPA t-shirt that we draw every month, and we'll ship that to your door if you're the lucky winner, free of charge. Lastly as well, if I can find it, there it is. Just because this is quite fitting given the topic of today's lesson, we have just released recently a YouTube video on how to perform booting transitions for motorsport wiring. So this is something we see a lot in professional motorsport wiring harnesses, where there are molded transitions where the harness branches out at different points, even the boots that we use at the back of the connectors as well. The idea behind this obviously is that it helps improve the reliability of the harness. First of all, it performs one job, which is strain relief. Any stress and strain isn't actually transferred into the connectors when we're talking about the boots on the back of them. Case in point, these ones here, which we will have a look at a little bit more in detail when we get into today's lesson. The other aspect there is it also seals the harness from environmental impact. So Zach takes us through a nice little lesson there on how to go about that. If you are interested in learning, head over to our YouTube channel. Make sure you check out that video. While you're there, subscribe. And if you like that video, please give us a thumbs up. If you've got any questions, please ask them in the comments. All right, just a last reminder about the engine building giveaway. We've only got 4 days left for that to run. Again, there is a link in the comments that you can follow to go through and get your name into the draw. Make sure you don't miss out. It is a great giveaway. All right, thanks for watching. Give me a few moments here and we'll get started with today's lesson.
If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.